Hello, brothers and sisters. Doc Knott here. Want to do another video. Going to talk today about significant figures and calculations. If you haven't seen my video about measurements and uncertainty, you might want to watch that first. That'll help you with some of that basic understanding that come into this. But otherwise, let's just jump right into this. All right, so let me share screens here. There we go. Okay. So what we're looking at here is we have calculations that are showing us that we have 5.02 times 89.665 times 0.10. And this is the answer you get from your calculator, and this is our final answer. All right. So if we look at this this number here, all of these numbers are significant. So we have 3 sig figs. Here, again, all of these numbers are going to be significant. So we have 5 significant figures. So this line is all just sig figs. In this case, the 0 is not significant. It's just telling us where the decimal point is. So there's really 2 significant figures. Every 0 after the decimal point is going to be significant. So that 0 is significant. We have 2 sig figs there. Now we're looking at the number of digits after the decimal point. Okay, so in the first number, there are 2 digits after the decimal point. We'll put a 2 there. Here, there's 3 digits after the decimal point. And then in this one, there's 2 digits after the decimal point, right? We don't really care about the raw number that's off the calculator. We only care about our final answer. So our final answer has 0 digits after the decimal point, and it has only 2 significant figures. Right now, one thing I want to talk about here, when we're doing multiplication, the reason why this has 2 sig figs is because this one here has only 2 significant figures. So we're going to go with the one that has the least number of sig figs. That's what our answer will have, the same as that. Okay. In addition and subtraction, it's based off the number of digits after the decimal point, right? So if we were doing addition and subtraction, it would be 2, because these two both have 2, 2 after the decimal, so it'd be like 45.00 or whatever. But we're not going to worry about that right now. We'll get to that in here. But what I'd like to say is the reason why it's important how many digits there are after the decimal point is it talks about the uncertainty. We talked about that in the last video, the uncertainty. So here, the last digit is our uncertain digit. Our uncertainty is in the hundredths place here. And here the uncertainty is in the thousandths place. And here again, it's in the hundredths place, right? So the largest uncertainty is in the hundredths place, which is larger than an uncertainty of a thousandth. And so if we were doing addition and subtraction, we would round based on that uncertainty. Okay, so let's look at these numbers here. We're going to add 3 numbers together: 1.74, 11.8231, 12.651. And so those are the numbers we're adding up. This is what we'll get from our calculator. And then we're going to round it to the hundredths place. Why at the hundredths place? Because the largest uncertainty that we have is this number here. It has an uncertainty in the hundredths place. This one has an uncertainty in the 10,000ths place. This one has an uncertainty in the thousandths place. Right. So we're going to round to the hundredths place, which is the largest uncertainty in this particular calculation. And we get this number here. So this one here has 2, 3, 4, 5, 6. That's 6 significant figures. All of them are significant. All of these are significant. That's going to be 5 significant figures here, right? Our final answer has only 4, right? Which is different than all of those. It has nothing to do with it, the number of significant figures in those. It has to do with the decimal places, right? So here we have 2 digits after the decimal place. Here we have 4, 1, 2, 3, 4. Here we have 3. And so our answer will have 2, just like this one here, right? So the number of significant figures was 2 here because of this one. And the our answer had 4 significant figures, but that was because of the number of decimal places, which was due to this number here. All right. Okay, so let's just kind of think about that a little bit. When multiplying, is the number of digits reported in the final answer limited by the number of significant figures or by the decimal places in the number being multiplied? For multiplication and division, it's based off of the number of significant figures, okay? All right. So when adding, is the number of digits reported in the final answer limited by the number of significant figures or by the decimal places in the numbers being added? For addition and subtraction, it's limited by the decimal places in the numbers being added, okay? But that's also true for subtraction. Okay. In reality, it's the reason why we do it that way is it's based off of the largest uncertainty. Okay. All right. So let's just do some significant figures here. It says round the following numbers. Oops. Move this forward so you can see it. Round the following numbers so that they contain 3 significant figures. Show your answer in standard notation and scientific notation. Okay, so 3 sig figs, that means we're going to round to that 3 there. And that 3 is going to be rounded based off the 7. 7 is larger than 5, therefore we'll round this up. And this will be 174,000. Okay, I'm going to do all the standard notations, and then I'm going to do scientific notation. Okay, so for this one, 3 sig figs is this digit here. That 2 will not round that 0 up, so we'll keep it as a 0, and this will be 0.00250. Now, these zeros are not significant because they are before the first number, and this one is significant because it's not only after that, but it's also after the decimal. Okay, so here we have 3 sig figs based on that. Now for 3 sig figs here, it's going to be this digit here. The 9 will not be rounded based on the 2. It won't be rounded up. So we'll keep it as a 9. And so this will be 0.000319. Now, for this number to have 3 significant figures, we're actually going to have to add a decimal point and another 0. So this will be 30.0. Now we have 3 sig figs. So this counts as a significant figure because it's after a decimal and it's after a regular number, right? Okay, so now let's turn these into scientific notation. So remember, scientific notation has 1 digit before the decimal and the rest of the digits after. So that would be 1.74. We only have 3 sig figs here, so we're only going to have 3 sig figs there, times 10. And this is moving this from the decimal. It goes 1, 2, 3, 4, 5 digits. So that's going to be a positive 5. Okay. This one would be 2.50 because we want 3 significant figures, right? Times 10. And this time we're moving this way, 1, 2, 3. So that'd be to the negative 3. All right. Here again, we have 3.19 times 10 to the 1, 2, 3, 4, negative 4. Okay. And then on this last one, this would be 3.00 times 10 to the positive 1. All right. So hopefully that helps. Let's do the backside here. It says round the following numbers so that they contain 4 significant figures. Write each answer in scientific notation and, in standard notation and scientific notation. So 4 sig figs is going to be this one here. And it's not going to round up because of the 4. So we'll keep it as a 4. So 249, 400. Now these zeros are not significant. They come after these numbers here, but they come before a decimal. And if we don't put a decimal point there, they are not considered significant. So we have 4 sig figs there. However, it's a little bit unsure. So the best way to write this number and show 4 significant figures is by doing it in scientific notation. So if we go ahead and do that, that'd be 2.494 times 10 to the 1, 2, 3, 4, 5 times 10 to the 5. Okay. Now we have for 4 sig figs here, it's going to be this 1. The 2 will not round it. So that'll be 0.002501. These zeros are not significant because they're before here. This one is significant because it's in between. 4 sig figs, going to be this 4 here. It's going to round up because of the 9. So this would be 1, 2, comma, 0, 5, 0, 0, 0. Okay, so these zeros and that 0 are not significant. This 0 is, because it's between those, right? All right, then this one here, 4 sig figs, is going to be this. It's going to stay a 0 because of that 1. So this is 0.02000. So 4 sig figs, 1, 2, 3, 4. These are not significant, right? Let's write this in scientific notation. 2.501 times 10 to the negative 1, 2, 3 times 10 to the negative 3. This one would be 1.205 for 4 sig figs times 10 to the 1, 2, 3, 4, 5, 6, 7 times 10 to the positive 7. Okay. For this one, it'll be 2.000 times 10 to the negative 1, 2. Okay. All right. I hope that was helpful. Let's go ahead and do some calculations and see how the sig figs work out in that. Okay. So I'm just going to show you my calculation on my calculator. So we have 0.987 plus 125.1 minus 1.22. Okay, my calculator gives me 124.867. We're going to do the sig figs after. I'm just going to go do all these calculations and then write my sig figs after, okay? So then the second one is 14.72 minus 6.8, and that's going to be 7.92. Okay. Third one, 17.8 plus 14.72 plus 16 gives me 48.52. So those were all addition and subtraction. Now we're doing multiplication and division. So this is 1.01, not minus, excuse me, times 0.12 times 53.51. Oh, and I have to now divide by 96. So I get 0.0067556.375. That's a lot of digits, way more than I need for sure. All right, let's look at the next one. 753 times 0.13 is 9789. 9789. Right, and then this last one here, 181.8 divided by 75, we get 2.424. 2.424. All right. So when we're doing addition and subtraction, we need to go with the number with the least decimal places, or the one with the largest uncertainty. So this one has uncertainty in the thousandths place, this one in the tenths place, this one in the hundredths place. So this one in the 10th place has the largest uncertainty, the least number of decimals. So we're going to round to that place. So this would be 124.9. We're going to go to this place, right? So that 8 rounds to a 9 because of the 6. And so that's our final answer. Here we have in the hundredths place and in the tenths place, we're going to round to the tenths place. That's here. The 2 does not round that one anywhere, so that's just going to be 7.9. A number without units is meaningless. That one's meaningless, but this one has a number, so that's going to be in centimeters, or that has a unit, centimeters. 7.9 centimeters. Here we have uncertainty in the tenths place, in the hundredths place, and in the ones place. So we're going to round to the ones place. So that's here. So this is the 5 rounds that to a 9. So that's going to be 49. We have grams plus grams plus grams. So this is going to be 49 grams. Okay. This one has no units, so we're not going to worry about units, but we have, remember, in multiplication and division, it matters how many sig figs the numbers being multiplied and divided by have. So here we have 3 sig figs, 2 sig figs, 4 sig figs, and 2 sig figs. So the smallest number of sig figs is 2. So we're going to go with 2 sig figs. So that would be rounding there. So this is going to be 0.068. Okay. The 7 rounds to an 8. All right. Here we have 3 sig figs and 2 sig figs. So we're going to round to 2 sig figs. So that would be this digit here. So this ends up being 9, 8, because that 8 makes that round up to an 8, 0, 0. Now that has 2 sig figs. Okay. It's not real clear though. So the best way to write this would be 9.8 times 10 to the 1, 2, 3. Okay. This would be the best answer. This is acceptable, but that would be better. Okay. We have 4 sig figs and 2 sig figs. So we're going to round to 2 sig figs. That's this 4 here. So this would be 2.4. And this is, oh, sorry, this should be centimeter times centimeter. So this is going to be centimeters squared. This is grams divided by mil. So that's grams over mil. And there we go. I hope that was helpful for you. And if that was helpful, please leave a comment below. Let me know what you liked, what you didn't like. And I will see you guys on the next one. Thanks. Bye.